lady named Helen or girl named Helen. Is that going to help us solve the problem? So what else do we know? We know there's 3 books. We know that there's a 20% discount. And we know that the $10 is not part of the discount. Okay? So what do we need to know? And in this case, don't tell me that we need to know each term, coefficient, and constant. What do we need to know to write our expression? So we're looking for the total amount. So do we have the total amount, or is that unknown? Is that what we're going to make as our variable? So what's our variable? What's unknown? We may have 2 variables, right? So we're talking about expression, right? It didn't say that we had to have 1, but that's a kind of a trick question. So what are we talking about? We're talking about books, and we want to know the total amount to pay for the books. All right. So hopefully you're thinking about some things. So step 1. Translate the verbal expression into an algebraic expression. So we'll let X represent the unknown price. We don't know how much the books cost. But we know we want 3 books plus shipping. So 3 times X plus 10 would be the shipping. And if it was that simple, we would be done. But we have that discounted price. So we have 3 times X, but we want to take away the discount. Notice this is a little different from the last one, because they asked you for the list price. They didn't ask you for the total amount with the discount. So 3x, $3, 3 per book, 3 books per price of the book, whatever the price is, minus 20% of 3 times x. Because you don't know what that value x is. You don't know how much a book costs, but you know it's going to be 3 times x. And that's what you're getting the discount on. Plus the $10. So now, how many terms do you have? Can you identify the terms? Well, before you identify the terms, let's go ahead and simplify the expression. So, the expression can be simplified by following the order of operation and combining like terms. And you guys, the way that I'm doing the PowerPoint, you're seeing everything at once. I probably would change that differently. Next time I will do that. But for now, we're going to keep it the way it is. So step with me one at a time. So we have 3x minus 0.20 times 3x plus 10. Well, if we multiply 0.2 times 3, we'll simplify that expression, or that term, and we get 3x minus 0.60 x plus 10. Combining like terms, well, we have 3x and 0.6x. 3 minus 0.6 is 2.4, and so 2.4 x plus 10. So that's our expression, our simplified expression. And so again, how many terms do we have? What's our coefficient? What's our constant? What are our factors? So our terms, 2 terms, 2.4 and x, and then the shipping cost, 10. The factors, 2.4 and x. What about coefficient? You're right, 2.4 is multiplied by x. You should see a connection between factors and coefficients. If there's a factor, then more than likely you're going to have a coefficient because it's 2.4 times x. And then identify any constants. And again, this is just a plain number without a variable next to it. So 10 is a constant. Looking at the table, The table will help you organize it if you're still kind of having a problem with it. Again, factors 2.4 and x, not necessarily 5 and 2 for 10. All right, this is the second part of our lesson. This part we're going to interpret complicated expressions. And so, algebraic expressions are used to describe various situations containing variables. Think about if you go to the movie theater and it's 12 of you guys going to the movie theater, so how much is it going to cost total? Well, what if it was 14 of you guys? What if it was only 2 of you guys? So ideally, the price doesn't change per person, but the number of people are changing. And so the variable would be the number of people, but the price, maybe it's $7 per person, would be 7x to figure out the total. So it's important to understand how each term of an expression works and how changing the value of a variable impacts the resulting quantity. If a situation is described verbally, it is often necessary to first translate each expression into an algebraic expression. This will allow you to see mathematically how each term interacts with the other term. As variables change, it's important to understand that constants will always remain the same. The change in the variable will not change the value of a given constant. If I was taking great notes, which I'm sure a lot of you are, I would write that down. The change in the variable will not change the value of a given constant. So no matter what you do to the variable, the constant shouldn't change. The whole expression may change, but the constant value will not change. So don't misquote me. Similarly, changing the value of a constant will not change the terms of the variable or change the terms containing the variable. And it's important to follow the order of operation, as this will help guide your awareness and understanding of each term. Remember, order of operation is one of those things where you've learned it in 6th grade and 7th grade, 8th grade, and we're kind of assuming you know it. Now we're just building on it. You still follow the same rules, even though you have expressions. And so the most common error or misconception is incorrectly translating the given verbal expression. So you need to know those buzzwords. So if someone says, I'm going to double it, or I'm going to half, take half. Double means multiply by 2. Take half means divide by 2. Okay, so you need to know words. If they say, what's the sum? They want you to add. Consecutive integers, every other integer. Okay, here's another example. So, to calculate the perimeter of an isosceles triangle, so I'm going to pause. What's a perimeter? Or what's the formula for the perimeter of a triangle? I'll wait. All right, so the perimeter of an isosceles triangle. Isosceles triangle, what does isosceles mean? If you don't know, I need you to look that up. I want to say that was one of our words at the beginning of the year. And those will come back again. So if you didn't do your crossword puzzle, or if you don't remember those words, don't forget I mentioned those. We'll come back soon. So in order for me to even go further from reading it, I really need to know what perimeter means or what that formula is for a triangle if possible. And I also need to know isosceles triangle, because it wouldn't make sense for me to read this and really not understand those things. And so, to calculate the perimeter of an isosceles triangle, the expression 2s plus b is used, where s is represented as the length of the two congruent sides and b is represented as the base. So isosceles triangles, they have two congruent sides. What effect, if any, does increasing the length of the congruent sides have on the expression? So the expression is 2s plus b. What effect, if any, does increasing the length of the congruent side? So changing S. If I increase S, so let's say S is 2. 2 times 2 is 4 plus B. B could be 5. 4 plus 5 is 9. Now let's say S is 10. 2 times 10 is 20 plus 5. Let's keep B the same just to be consistent. 5. And so then you have what? What does it do? Does it increase it? What does it do? All right. So changing only the length of the congruent side will not impact the length of the base since B is a separate term. If the value of the congruent side S is increased, the product of 2S will also increase. Likewise, if the value decreased, it would also decrease. If the value of S is changed, the result of the change in the term is a doubling of the change in S, while the value of B stays the same. So that term, 2S, would definitely change. It would double. In our case, we use 5 and 10, so 5 and 20. Okay? Here's another example. And you guys, we're going to spend a lot of time talking about exponential. And so I'm going to give you a heads up. This is not linear. It's exponential. There's a formula that you've seen before on a sponge maybe or a pretest that you'll see often. The N and the T is interchangeable. So money deposited into a bank account earns interest on the initial amount deposited as well as any interest earned as time passes. This compound interest can be described by the expression P parentheses 1 plus R raised to the N, where P represents the initial amount deposited, R represents the interest rate, and N represents the number of months in that pass, or N represents the number of months that have passed. So how does a change in each variable affect the value of the expression? So again, we have P parentheses 1 plus R raised to the N. Alrighty, so notice the expression is made up of one term containing the factor P and 1 times or 1 plus R raised to the N. And inside of there, 1 plus R, those are two terms. But remember, a term is separated by a plus or a minus. So as a whole, that's just one term. Changing the value of P does not change the value of the factor of 1 plus R raised to the N, but it will change the value of the expression. So in other words, the change in P will multiply by the result 1 plus R raised to the N. And so if P is 5 versus P is 6, it's not going to do anything to that factor, but it will do something to the expression. Similarly, changing R changes the base of the exponent, but does not change the value of B. The base, some of you guys had all kind of vocabulary words for base, but the base is the number that will be multiplied by itself. So this change in R will affect the value of the overall expression. Changing N changes the number of times 1 plus R will be multiplied by itself, but does not change the value of P. This change will affect the value of the overall expression. All right, so I'm going to go back to the beginning and just repeat one more time.